Hello and welcome back to Advent of Code 2024, day 19. Welcome in, DJ. Time for 4 hours of coding, do you think? Have you heard anything about this problem? Or was that just a complete guess? Ooh, little AOC 10 years in there. I've not really looked at this picture properly. So it's spelling out the word 10 because for the 10th anniversary. Like, oh, okay, so that's a Christmas tree. So it's referencing the different things that appeared in the problems. Although they're a bit obscure. Is that falling sand? The falling sand problem was a very famous one. Just guessing based on yesterday. Oh, I see, yeah, because yesterday was very easy. Alright then. Is it going to be involve more grids? No grids today. Okay. Some people will be happy about that. I quite liked the grids because I was getting a better and better like grid class where I was updating it with more and more functions. Day 19, linen layout. Today, the historians take you up to the hot springs. Oh, I remember the hot springs. Ooh, I remember this one being a tough one. Well, it wasn't tough in the end, but I got stuck for quite a while on this one. On Gear Island. Very suspiciously, absolutely nothing goes wrong as they begin their careful search of the vast field of helixes. Could this finally be a chance to visit the onsen next door? Only one way to find out. Oh man, when I was in Japan this year, I never went to an onsen. Probably, there's always next time. So a brief conversation with the reception staff at the onsen front desk, you discover that you don't have the right kind of money to pay the admission fee. However, before you leave, the staff get your attention. Apparently they've heard about how you helped at the hot springs, and they're willing to make a deal. If you can simply help them arrange their towels, they'll let you in for free. Every towel at this onsen is marked with a pattern of colored stripes. There are only a few patterns, but for any particular pattern, the staff can get you as many towels with that pattern as you need. Each stripe can be white, blue, black, red, green. So a towel with the pattern GGR would have a green stripe, and then a red stripe in that order. Okay. The official onsen branding experts produced a list of designs, each a long sequence of stripe colors that they would like to be able to display. You can use any towels you want, but all of the towel stripes must exactly match the desired design. So to display the design RGR, you could use two RG towels and then an R towel, an RGR towel and then a GR towel, or even a single massive RGR towel. To start, collect together all of the available towel patterns on the list of desired designs. The first line indicates the available towel patterns. In this example, the onsen has unlimited towels with a single red. Okay, yeah. After the blank line. Six of the 8 designs are possible with the available towel patterns. To get into the onsen as soon as possible, consult your list of towel patterns and desired designs carefully. How many designs are possible? Okay. This one is, I think, recursion should handle it with maybe. Would we need caching? I don't think it would be needed. Oh no, caching not string, but caching on the index. Yeah, that would help. Okay. So oops, I copied the stream title. How did I manage that? Okay. Okay. So I guess it's easy enough to get the input. So towels. Towels equals f dot read line dot strip dot split on comma space actually. Then we'll f dot read line, and then wait, so if I now do for line and read lines, which line is it gonna do? Start from the beginning. Oops. Never really. Yeah, it starts from where we left off. Yeah, okay. So for line and read lines, let's just get the input into an array. So we've got designs. Designs dot and line dot strip. All right, so that's our input, and we want to say, all right, so for given a design, we want to see if it's possible, given the tiles we have. So define is possible for a given design. Just write the most basic recursion, see if that works. Otherwise, we have to add some caching. So we want so yeah, I'm guessing actually we probably will need caching. It's possible. So we want. But yeah, like I said, we'll just do it without. So we'll say for towels, a towel in towels. Or should we just say So actually, we need a index into this so that we don't keep passing the string around. Hello, Smab UK. So to start off, we just start with 0. So we want to check if design from start up to length of tau start plus is, wait, so this is a string, isn't it? Should really be dealing with, well, we're not passing substrings around, so I guess that's fine. If so design, if the design starts with this tau, if is possible. So we have an infinite number of these taus, so we can reuse them. That would make it more complicated if we couldn't. It would be a more of a without replacement backtracking method. All right, so if is possible, psi. This time we start from start length tau. Then we return true. Otherwise, return false. So we didn't do any caching. Let's just see if that works as is. Because we're going to revisit indices here, it's probably really slow. Well, yeah, okay. What was something I needed to tweak? Oh yeah, the base case. If start equals length of design, return, it's vacuously true. Or greater when you got to length design, don't think that can really happen. Return true. No, we'll try this. So we print sum of is it just map of is map of designs is possible. Function object is not. Oh, wrong way around. I always get confused with map. And it's going to be too slow, isn't it? Okay, it's a good first step. All right, next we need to cache indices because we were just reusing indices over and over again, potentially exponentially many times. So we can use caching. When did I do that before? Somewhere. I have to go through all these again. Start from. It was earlier than this. 16, 14, 13, 12, 11. Cache, there we are. Now, I don't think... we can just, can we just do that? The problem is I don't really want to be caching the, This might be a case I want to write my own cache or not. Maybe it's just sufficient. See, the thing is we don't want to necessarily keep caching the design itself. We just cache the index and then we want to refresh the cache between... Oh, but it's just caching a pointer probably, so it's... No, this is... No, it's going to cache the entire string. That's okay. I think it's fine. Okay, just adding cache works. Ideally, I would just cache the pointers, the start pointer. But then you'd need to delete the cache between designs, that's the issue. Alternatively... we just cache the index of the array. So this should actually be the array index and get the design from that. Then we're just caching an index. That's actually worked much better. But then we have to... Anyway, let's just check if it's the answer. Correct. Part 2. The staff don't really like some of the towel arrangements. Oh, you came up with. To avoid... Hang on. Avoid an endless cycle of towel rearrangement, maybe you should just give them every possible option. Isn't this just like... easy change. Alright, let's so we want to output the number of different possibilities. This is just basically instead of is possible, just say num arrangements design starting with 0, so this should just work. It's the same, going to be the same complexity. It's doing the same thing, except it doesn't break early, so it doesn't short circuit. So it'll be a bit slower, but should be roughly the same anyway. If sign is that result plus equal arrangements that return result. It's just that. We'll add in part 1 back later. Let's just check this. It's that. Is it that simple? Correct. That was just about the easiest part 2 we've had yet. If you've done part 1. Like, I don't even really see how you could have done part 1 in a way that would make it hard to do part 2. Like, your algorithm has got to be covering all arrangements in the worst case anyway. If it doesn't find, I don't know, if something has a lot of prefixes. Yeah. Yeah. That was the quickest part 2 ever. That was also pretty much the quickest I solved any problem lately. Even Even part 1 took me like a couple of minutes longer, probably. Yeah. I mean, I can see people getting stuck on that because it's dynamic programming, and dynamic programming is always confusing. Python, of course, has cache, which definitely helped a lot. So if I were to just finish this off, I would say... So we've got num arrangements. So this is just gonna... So for part 1, it was faster to short circuit as soon as we find a true, but I'll just stick with this for part 1. So we just say part 1 print sum of so we want num arrangements of design equals 0. It is greater than 0 for designs. What is that? Yeah, that's it for my final program. I'll just leave it like that. So yeah, for part 1, it can be done better by even without the built-in cache. C# solution is pretty sure. Yeah, I mean, I was about to write my own cache anyway. That's pretty easy. It's just the index. Either you just do this one index, and then you clear your cache between designs, or I could just have the design index have 2 indices that would basically be equivalent. Yeah, I mean, years ago I can see myself getting tripped up on this because I probably wouldn't immediately see the way it's done dynamic programming problem. I'll probably just write some sort of backtracking method, but probably won't make it efficient or whatever. And how fast is that run? Yeah, pretty fast. So I mean, I don't really care about speed anyway, but I wouldn't bother caching the index here. Yeah, cache is great. I need to look more into exactly what cache does behind the scenes, but I mean, it's not... I guess it's caching the whole string. Yeah, because string is a immutable, so that's ever so slightly less efficient than just caching the pointer. But it's fast anyway. Well, maybe he is caching the pointer, I don't know. Yeah, I'll take a look at yours. Alright. One where it's possible, so we've got that. Oh, that's interesting. Design is patterns.where design starts with .any. Yeah, okay. Hash.try get value. Alright, yeah, it's pretty good. Alright then. I get my day back early today. only 25 seconds today. 6 seconds, come on. That's the most ridiculous one yet. Okay. Well, one thing I never really look at is that page. Let's have a look at this. It gives a rough. It's difficult to really glean anything from this, but I used to look at it more often. But it's the more grey you see, basically, the harder the problem is. So it doesn't. Okay, so like this one seems to be a hard problem. 6. What was this one? God. Oh, I see. Yeah, I think some people found this one a tricky. Because it had a lot of computation. Day 2 has a high failure rate. I don't even remember this. Okay. Well, early days, I guess there's a high dropout rate because some people are just experimenting with app intercode, so maybe a lot of people just dropped out early. Day 12. Yeah. Oh yeah, definitely. This one was tricky. And recently, so 15 and 16 maybe a bit tricky. Oh yeah, definitely. This would be hard to code for the part 2 certainly. Oh yeah, of course, the grey star is only 1 star, so I guess this is what I'm looking at is really an indication of how hard part 2 was compared to part 1, the ratio of gold to silver. So, and 17 was int code, of course. Int code, that was definitely a very tough part 2. I'm surprised the well, that is coming to close to 50-50. That is quite a low part 2 rate, I guess. I'm still missing 16 part 2. All my tests pass, but I can see it is taking the wrong path. I hate maze walking. Oh, the reindeer, yeah. Taking the wrong paths, so it's giving when you say taking the wrong path, you're doing a more heuristic search, or are you doing BFS? Because I think if with something like BFS, it should just take every path, right? Or you mean you're outputting a wrong path after reaching the goal? When I'm searching for all paths, I'm missing the shortest ones. Have some silly bug somewhere. Okay. Is there a reason you're searching for all paths though? For part 2? Interesting. So you're taking all... Okay, so you're going turning it the other way around, at least from what I did. You're looking for all paths, and then seeing if things... So you're looking for all shortest path to be found for what 2? Well, not really. I think the way a lot of people did it was just find any best path, and then just when you add, and then you just iterate through the bytes dropping, and when you drop a byte, you just run BFS again and see if you can reach the goal, and that tells you whether or not oh, am I thinking of the byte? This is not the byte problem, is it? Oh my god. Okay, forget I said anything. I'm mixing this up with the byte problem. Oh, it's this one. Okay, yeah. How many tiles are part of... Oh, yeah, you're right. Yeah. You do need to... Okay. Yeah, that felt similar to the byte problem, even though we don't get given a grid there. Yeah, no. Yeah. I think you already know how to do the part 2 efficiently. Alright. See if anyone else is doing this then. Snow cone. I think I might have raided them before. C sharp. Alright. Someone's playing Satisfactory. That's kind of like coding. Oh, the Satisfactory any percent and Advent of coding. Well, they're doing both simultaneously or just one then the other? No, right now they're playing Satisfactory. Okay. Using Satisfactory to do AOC. Wait. Are they? No, they're doing Satisfactory 80%. If they were, then I would definitely raid them. No, they're actually speedrunning it. Oh man. 6 hours. They're doing no glitches. Because when you use the duplication glitches, then you can bring it down to under an hour.
That's fine.
But
we'll do at least this much.
Man, I could never speedrun my Satisfactory on my laptop because you probably need a really good CPU and RAM too. Does that say the next split is 49 hours? No, it's send package 4. It's not very clear. Because there's like 5 packages. Alright, well, I'll raid the other one then. Alright, thanks for watching. See you tomorrow. Maybe. I've got yet another flight tomorrow. Probably see you tomorrow. Later in the day.